Hello, everybody, and welcome back to another lesson continuing our law of sines. But if you notice what it says up there, two triangles? Yes, we could get two triangles from our data instead of one like we're used to. Why? Well, if you've been through my classes before, you know math is a very fickle beast, and it doesn't want just one solution, it wants all the solutions, anything that could work. So we have to try it out. So let's check this out. Notice A is 12, side B is 31. If A is smaller than B, something like this could happen. We could get a triangle that looks like this. Okay? Or we could have this triangle. Ooh, if you guys could see. Could have this triangle, could have this triangle. We don't know which is the correct one, so we got to find them both. So I'm going to start with this triangle. So we know here is 12. So we'd like to find angle B first. So, law of sines, we're looking for an angle. So, sines on top, sine of 20.5 over 12. Ooh, it's not writing. Oh, still wet. Over 12, that's a 12, equals sine of B over 31. Multiply the 31 up, do all the math out, and you get 64.8 degrees is B. 64.8. Now, I could do 180 minus those two if I needed to find that third side. So 84. So about 95 degrees if I want to figure that out. And then I could do law of sines to find the third side. Okay? Now, let's look at this other triangle, because we should be able to understand that. We went this way, but instead, we would have this triangle. Now, notice, right here, we have an isosceles triangle. This side must equal this side, as we've shown. That means this angle must equal this angle. So if that angle is 64.8, that angle is 64.8. Well, how do I find this new angle B? Well, 180 minus 64.8 gives you 115.2. So now I have this brand spanking new triangle, ABC, well, that's 115.2. That's 31. That's 12. That's still 20.5. Right? Right. So now let's do law of sines all over again. Yes? Well, that's 44.3. I don't like using angles over 100 on this. So I can do, we're looking for a side, so 30. I lied. Don't do that. So I can do 12 over sine of 20.5 equals side C over sine of 44.3. Multiply that out. And what do we get for the third side? 23.93. 23.93. Of course, that's centimeters. Boom. And then there we go. Two complete triangles. It's kind of tricky, but notice again, isosceles triangles. I know it doesn't look it. I'm a mathematician, not an artist. But do your best with these. If you have any questions, let me know. Be safe in the quarantine. Stay safe.